I'll
So,
just do the introduction first for all of our instruments,
mm,
and then we'll go into the hands-on session with the SOLOS.
okay, good. Good. So we have here the two doctors from the medical team, Dr. Hương and Dr. Đào, and
Hello, hi,
also
doctor.
yeah, also Tiên and Le is the one you know already. Yeah,
Yeah, we met already.
yeah, you know.
Okay.
Okay. Yeah,
So
yeah, we can start.
we'll try. Yeah. Yes, go. Okay. Let me just introduce myself and my colleague. Shenwen and me is the application team from TIM. So if let's say you do have any requests in terms of training or more information regarding the instruments, please email us at our email we have right now. It's just me, Izo, and also Shenwen. But if let's say in terms of a different instrument, we can actually refer to our other team members as well. Okay, so let us start. I'm just going to do an introduction first.
So do you share anything on the
Yes,
screen?
I will share my screen with them.
Okay. So thank you so much for organizing such a series of training. So it took a lot
Sure.
of time from you. Appreciate, really
No
appreciate.
worries, no worries, no worries. So please, it will be because the session is continuous. It will take a bit of time, but we'll try to do it as casual as a discussion as possible, so you are open to ask questions. But for this session, I think it's more direct. I'm just gonna show you what we have. Okay, sure, it's okay, right? Okay. So this
Yeah,
is our
okay.
portfolio.
Full
Yeah.
screen already.
Okay. So we divide our instruments to four categories. We have examination, diagnostic, treatment, surgical, and also data management. So it's easier for us to just categorize into these four categories. So at least you know who to refer to as well. Okay, so just remember this. I'll just go through examination. So this is mostly my portfolio. You can ask me regarding all of the examination instruments, but you can also ask me for other instruments. I will do a discussion with my team member as well. Okay. So most of the time for examination, we we do product reference, we do product training, and also demo internally. We can help in terms of tender requirement, firmware updates. So this is all within our job scope. Okay. So as introduction, so we have all these main categories. We have autoref, we have tonometry, we have lens meter, vision tester is a productor. Refraction system is more towards a whole complete set. So if let's say you want one machine that have everything, what you see from here, autoref, lens meter, vision tester, and also vision acuity chart would be included inside the refraction system. So, and then we have the SP1P, which is the corneal specular magnification. So you can see the endothelium layer. Okay, if let's say autoref, we have all the series. We will go in that a little bit more later on. I think tomorrow. So I'm just going to do a little bit of introduction. So we have KR800, KR1. So each of the numbering or the character you see on the machine have some meaning to it. So KR is keratometry and refractometry. So there's two functions inside the machine. 800 is the latest series that we are using right now. So that's the basic understanding from the codes. So KR, you know, it's a keratometry, autorefractometry, and one is automated function. So basically, it's a one-touch function. And if let's say you switch to this, if let's say the KR1W, we have wave wavefront technology, so meaning you can do barometry as well. And TRK3 is the I would say the most complete in terms of function. We have tachymetry as well, we have keratometry as well, tonometry, and autoref. So newer version of our machines, we will call it with the name. So the latest one from here is Omnia. Okay, that's in terms of autorefractometry. So for people who are quite new to this, don't know what is autorefractometry, is actually the machine to check the power of the eye, the power of your spherical power, and the power for your astigmatism. So it's a total power measurement. So it's not limited to only cornea or lens. So that's the machine that we have right now. So if we talk about tonometry, this is non-contact tonometry. So it's not gonna have any part of the machine touching the eye. It's utilized air puff technology, so it will push out air puff at the nozzle, and it will push the cornea, and from there it will try to measure. It will get the measurement of your eye pressure. So as you can see here, this is a couple of machines that we have in our TopCon portfolio. CT800, CT800A, CT1, CT1P, and TRK3, which have both tonometry and also autoref and keratometry. Okay. So from these two, especially the newer people, Tian and Toy, right? Do you have any question for now? So it's a very surface, just introduction for the machines. Everyone okay with it right now?
Lợi với cả Tiên.
Loy, sorry, Loy.
Yeah, yes, I'm
Yeah.
okay.
Yes. You okay? So everyone is familiar with the term tonometry, autoref, and also keratometry, right? Okay.
So we have
So
Thịnh just joined, and I think soon I think we'll have the first Omnia TRK3 in Vietnam.
I see. That's cool.
Yeah.
That's the one of the
Almost
newer
done.
models that we have. So it's quite interesting to actually explore the machines. The interface also look nicer. It's a bit faster compared to the previous DRK2P. Okay. Okay, so I think today we focus more on lens meter. Later on the demo here on site, I will show you more towards the SOLOS. But we'll go through CL300 and later on as well, if we have time, okay? So if let's say we go through it, don't worry about all the other models that we have. All the models would have a lot of variation, especially autoref and tonometry. If you notice here, this is just for, I will go into it a bit more with another slide that shows all the variation that we have with the KR and also the CT. So just don't, the thing about KR and CT, it's more towards knowing the variation and the functions. Once you know that, you already know which one you want to order for your customer. So there's a lot. It's not just four. We have like 7 for just the KR series. Okay. So lens meter. Just gonna have an introduction for the SOLOS first. So let me just go. I think we'll just go into it later on. So this is all the lens meter we have. We have 3 types: LM8, CL300, and SOLOS. LM8 is a fully manual. CL300 is an automated lens meter, and SOLOS is a lens mapping analyzer. So I would usually say SOLOS is not really a lens meter. CL300 and LM8 is more towards lens meter. SOLOS is a lens mapping analyzer. So it's, I would say, a different category because you don't really use it for QC or to check the power accuracy. It's more towards upselling and to see the property of the lens. Later we'll see together. Okay, this is all the function. I'll go into it later on. So in terms of examination, we have vision tester as well. So this is the phoropter. We have manual phoropter VT10. We have the automated phoropter CV5000. So we have the newer model CV5000, which is white color. I think it will be updated later on. I will show you what's the main difference. So this is the Chronos. Chronos is a refraction system. It has the chart inside. You have the autoref inside. You have also the lens subjective measurement inside the machine as well. So it's a complete system. It takes roughly around 2 by 2 mm only. It doesn't take a lot of space, but you can already check the power for each patient completely. So this is basically the component inside the Chronos. So we have autoref, phoropter, chat as well. So this is the interface. It's quite convenient because you can use it with a tablet. You can use it with a PC as well, depending on what kind of setting. So this is the chart. I'm sorry, we have one more. We just launched the one in our region, which is CC100. It will be included later on, so don't worry. So ACP8 is a bit more manual. It's a projected chart. PC50, which is a digital, and MC5 is a mirror chart. So each chart have different distance. So this distance actually help you determine what kind of chart you want to sell to your client, because it depends on the refraction or the dark room. How big is the size of the room, then you want to put in which kind of chart. So before you order a refraction system, any CV5000 or a VT10, just determine the size of the refraction room first, and how to actually help with the sizing, you need to know which kind of chart as well. So once you choose a chart, then it makes it easier for you to order which phoropter for the chart. It's quite important step. Okay. So SP1P, specular microscope, it gives you the endothelium measurement. If you notice here, you can have a picture for the endothelium. So we have panoramic size as well. So basically have grade of three grade of the endothelium shape and sizes. So we'll go into deeper later. So don't worry about it. So this is one of the machine we have as well. I think last time I visit Hanoi, we already have a SP1P. So this is quite, yeah, quite, I think it's a very important information that ophthalmologists need to have as well. Because once the endothelium is not in a good condition, it's a bit harder for the eye to have the recovery of the eye. So it will lead to the decision of the ophthalmologist whether they want to do surgery or not, or which kind of procedure they want to do. Okay. So for examination, uh, we are done going through. Beside the one I show you, mostly it's not directly from TopCon. It may be coming from our distributor, which is maybe Vogtland's, Enier, our Edger. We'll touch on that as well when we go through certain instruments. Okay. So for diagnostic, so I'm just gonna skip this. So this is diagnostic instruments. So we have Hansen, which is our perimetry. We have OCT, which is the Triton 2, sorry, Maestro 2 and Triton. So just for information for you guys, Triton 2 is launching within next year. So I'm just letting you know now, the Triton 2 utilize new ImageNet 7. So you would have a little bit, you have to get ready in terms of software as well for the new OCTs. So moving forward, we will utilize ImageNet 7 instead of 6. But in terms of the interface, it looks very similar. you would feel that it's something you can go through, navigate. Once you get to know ImageNet 6 you're familiar with, then ImageNet 7 would feel very similar. Just couple of button or couple of interface would change slightly. So this is OCT. And then topographer, we have three, CA100, Aladdin Maya, which is our biometry for Aladdin and Maya. I think you guys are well aware of Maya capabilities and also coming in Aladdin. So this is from different um, manufacturing plants. So if let's say the one I showed you before, majority all of them is from Japan. So if let's say on diagnostic, Hansen is actually from UK, the plant is different. OCT is still from Japan, and topographer Exelan, this is all from Visia, which is from Italy. So, and then even though I already showed you wavefront analyzer before, it's still considered diagnostic as well because some anterior segment specialists, corneal specialists actually want to have some information in terms of the the distortion or the aberrometry. Okay, so and then we have the slit lamp. Slit lamp as well, you can do with camera or without camera. And the last one is fundus camera. So this is all within diagnostic. So Hansen, it's a very straightforward perimetry. It doesn't have a lot of variation in terms of the test, but it's a very um, accurate and fast test compared to if you guys are familiar with Sita Fast or Sita Faster. It's very similar in terms of speed. If let's say you compare with normal Sita, this is even faster. So the algorithm is slightly different. So Smart Supra and also Zata uses another algorithm to make it a bit faster, to make it easier for operator instead of waiting more. Because some of the tests we can just extend to a bigger range of perimetry. So it's a very good perimetry and comparable with the Humphreys HFA. Okay, this is our Maestro. I think later on diagnostic will actually uh, give a little bit more details, and also we are planning to do a retina workshop later on. I think maybe after APAO, so you will have a little bit more advanced knowledge in terms of OCT. So I'm just gonna roughly just glance through OCT only. Okay, Triton. So main difference between these two, this is SD OCT, which have a speed of 50,000 scan per second. So this is a SSOCT, 100,000 scan per second. Penetration is better. So if let's say you have hemorrhage, you have opacities on the lens, it will penetrate better compared to the Maestro 2. Okay. So if let's say you talk about topography, you have this three, CA100, Aladdin, Maya. So a lot of diagnostic tools would have an update for for next year. So just keep that in mind. There's a new CA 800 and also there's a new Triton coming out next year. Sorry, later this year. Okay, this is our slit lamp. We have multiple. We have Zeiss type. We also have hard strike tower type for slit lamp. It covers both LED and also halogen. Our slit lamp is considered to be one of the best slit lamp. So it's our breadwinner. So I would encourage if you guys to promote our slit lamp as well. It's quite good. So this is the older version. A lot of this TRC NW8 is will slowly phase out. So try to not focus on NW8 anymore. 50DX is the only later on for funders, FA and ICG. So if let's say you do have a customer who wants funders angiography or funders ICG, the only machine that is able to do that is our TRC 50DX. DX. Okay. So there's one more funders camera I didn't put here, but later on we have just one exclusive session just for our funders NW500. So don't worry. Okay. So treatment wise, I'll go through as well. So we have Pascal synthesis. Twin Star is already discontinued. So 532, 577 is still possible to get. So, and this is Iridex 532. And also the one in Vietnam is the Pascal, Iridex Pascal 532, right, Kong? That's a new one. The one we had last week.
Yeah, the one is
532, right?
532. Yeah, in Da
532
Nang.
with micropulse, right?
Yeah, with
Yeah.
microphone.
So yeah. So congrats, you guys. Even for Malaysia, we're still ongoing. We haven't closed any Pascal, Iridac Pascal yet, but we do have a lot of Pascal synthesis in Malaysia.
Yeah.
So a lot of them, if you have any hospital who are familiar with the Pascal synthesis, try to encourage for further upgrade from that because they are already familiar. They know what to do already. Just you can give the update. If let's say you go for Pascal, Iridac Pascal, you can get micropulse together with the Pascal.
Yeah, we do focus on that kind of customer because we have some Pascal synthesis. I think it's more than 10 years already.
Yeah. We are doing the same thing. We're trying to convert the Pascal synthesis to the new Pascal Iridac. It does have more function and it's a bit more convenient because a lot of the time when they sell Pascal synthesis, they want the laser to be movable. So Pascal synthesis have a problem with there's two parts to it, the energy module and also the slit lamp. So there's two different components you have to bring around. But if let's say you talk about Pascal, Iridax Pascal, you can just move everything together. So it's quite convenient.
Right. Okay. It's a good point.
Yeah. So okay, then about Iridax, we have 532 and 577. So we have Oculite TX, Oculite GL, IQ 532. All of this is models that some we are phasing out already, and some is still possible to do, but we do encourage you guys to just get the newer models because we don't know when the components for the older model is going to be discontinued. So we just encourage if you can get the newer models, please go for the newer models. Okay, Iridex 577. So right now it's just for IQ 577. And then for 810, we have Ocular SL. X SL is already discontinued. So only SLX and also Cyclo G6. So both have different features for you guys to talk about. So in terms of microscope, we have OMS 90, which is a bit more simple, more towards anterior minor surgery, and you have the OMS 800 for a little bit more advanced surgery, and 800 office for posterior surgery as well. So this is Pascal Redux. This is synthesis. So newer one is Pascal Redux. Sorry, I think Shenwen will cover the newer models in the future. Okay, that's all the Iridex Pascal we have. So in terms of Pascal Iridex, especially the lasers, you have to be familiar with the accessories because it has each accessory give you different treatment. So if let's say the ophthalmologist wants certain like pattern scanning or they want endoprobe or they want BIO LIO lasers, just make sure you are familiar with it because you can actually do mix and match with adapter and also different slit lamps as well. And sometimes they have like a hard strike. They don't know whether they can just use the hard strike slit lamp with the Iridex laser. It's possible. Just to make sure you have the correct accessories. Okay, so Psychology 6. I think my colleague Shenwan will cover this a little bit better in the future. Yeah. So this is OMS. So and this is a basic laser OMS 90 and OMS 800. Okay. So in terms of data, Our software. So basic understanding of software is first we have the EMR from the hospital. It will talk with intermediary software, which is we call it PACS. So we have Harmony and Pliny. So right now we are focusing more towards Pliny. Harmony is limited to Europe market only, but it will communicate with the EMR of the hospital. So, and then from the PACS, we connect to ImageNet software. So this is the basic understanding of software. Later, if you have question, we'll just take it in the another session because this one is a totally different, I would say, different animal altogether. Okay.
So we have the separate section for this one, for the
Yes,
connectivity.
we have one
everything.
more. Yeah, we have just for software. I cannot go in that, but I'll try to ask Chi to be there as well. So you can ask in terms of software, what kind of software that you want to apply to, especially your for MSG, because they
Yeah,
requested
right.
Harmony, but we only have Pliny. So all this you just need to understand in terms of the infrastructure, whether it's an intermediary or it's the direct DICOM software. Then you can understand which one you need.
Yeah, they
Okay.
keep asking me about this.
Yeah. So later on, we'll just go through again. So don't worry. This is just the basic graph. Chi is here as well. I think Chi is okay with this, but later on we'll be together and we'll talk about software a little bit deeper. So software, for you guys understanding, we have three main software, but the one from TopCon is actually ImageNet 6, which is our image analyzer and also data management. So we can connect to most of our machine, especially the newer instrument. It's possible to connect with ImageNet 6. Okay, so this is all the interface. Later on, I think you will be very familiar with how to actually use, especially with OCT. There's a lot of features that you can actually connect with ImageNet 6. So this is an example of OCTA in ImageNet 6. So we do recommend just going with the newer software. It's easier, more friendly compared to the older software. Okay, so this is OCTA. And this is cleaning. If I already help us do a little bit of slide for cleaning. So it's basically a pack. So in intermediary software that could translate DICOM imaging software. So ImageNet 6 would probably output two types, DICOM and also XML. So there's two type needs to be processed and transferred to the EMR or EHR. So it's basically intermediary software to translate all the DICOM language and also the XML language to HL7, which is the EMR and EHR software. So once you have all the information, it will translate it to HL7 and give back to EHR. So that's the basic understanding of Pliny. So this is an example of the interface. It looks like, it does look like a patient management apps, but you can actually put in all the DICOM imaging and also JPEG. So over here is a report from all our instruments. We have the Hansen as well and the Topo. Okay. So, yep, this is what we are going for later on. So with the intermediary software packs like Pliny, we can integrate AI as well. So we are trying to get a couple of companies to work together. So hopefully right now in Apple especially, we are trying to integrate the Iris AI funders with Pliny. Hopefully we can get it done and get it to work. So we'll see in Napa. We'll try to contact both parties to make sure it works, but we'll see later in February. Okay. Okay, so that's for software as well. So I cover everything. For now, do you guys have a rough idea of all where the instrument on which category, treatment, examination, and diagnostic? Everything's okay?
Tiên Tiên với Lợi,
Yeah.
mấy
Is
anh
it
em
too
thì chắc là
fast? You have to let
ok
me know.
rồi, nhưng mà còn Tiên với Lợi mới thì các bạn có câu hỏi gì không? Tiếng Anh, tiếng Việt thì đều được nha.
Everything's
Can you
okay?
show me a step-by-step application for SOLOS?
Later.
Step by step. Solos, how to actually use it? Don't worry, I'll actually show you how I do inside. So it's on video as well. You can actually double check what's the step, what you have to say regarding Solos.
Application for optometric, step by step.
Application, what do you mean?
Um, uh, how to use SOLOS
Yeah.
by
I'll,
application.
yeah. I will show you what I do as hands-on, so don't worry about it. So try to
Yes.
follow certain features that I will show. I will show you how to actually clean as well, how to actually open the machine. So don't worry. But it's a hands-on session. I will just show it directly how I show to customers. Is that okay? Okay.
But I need to show deep in the application and how to use uh, the,
Okay. So I'll just do the demonstration first, and later on, just let me know which one you're not that you miss or what you didn't get from the demonstration, because it's not really about the steps. It's about explaining the type of lens and how to actually upsell. So that's the main point of Solos. So if let's say we show you how to actually do, it's one part of it, but you have to actually promote how to actually get the data, how to interpret the data. That one is a different story. Okay, but I'll just show you what I have in our slide first. I think you just want step by step how to actually start the demonstration, how to which button to push, which button to show, and also the setting you want to show. But I'll go through one by one later. If you're still not clear, I will try to refer you with a couple of videos, and also if you're still not clear, I will do step by step with a slide. So don't worry. Okay? Yen?
hey Isu. But I think I need you to uh record a video to step by step about how to use SOLOS and I think
Yeah.
match two and try that
That's a bit hard, step by
because
step for Triton and Menstrual.
how do you
You have to be there.
from
There's a lot.
yeah
Yeah,
and
yeah. It's
application and
mm,
reach the
sure, but I will refer you to a couple of videos. Would help? So because in terms of functions for machines like OCTs, there's a lot of steps that you need to remember. It's not just OCT. It's for operator how to talk with the ophthalmologist, how to talk with the operators, how to actually put the accessories in. So there's a lot of steps. But it's actually available in our YouTube, and also if you have the opportunity to do hands-on, try to do it yourself directly.
Yeah.
But we do have a couple of step by step. It's just it's not complete because there's so much steps.
I think we will
Okay.
take back the demo machine to the office, and then we have a chance for the team to practice.
Yeah. So as I said as well, we do have a very we have a retina training later on after Apau. So please join. It will be led by Nora as well, and we'll just focus on OCT.
After how
After Apau, we will try to do an online session.
online section, right? That's good.
Yeah.
Okay, that's good.
So please join that one. It will be a very in-depth session. From identifying lesions, how to actually use the white field, how to actually use the interior. We will try to cover whatever we can regarding OCT and retina. But once everything is set, we'll send an invite. Don't worry.
Yeah, okay. Thank you.
Mm-hmm.
Okay, go ahead.
Okay.
Go ahead. And
So,
if we
okay.
have more questions, we can discuss later.
Sure. So we're just gonna go through the lens meter first. So I just separate lens meter and lens analyzer. So as you can see here, LM8 is a manual lens meter and CL300 is an automated lens meter. So this is what you choose if, let's say, the clients want more edging, they just want to cut lens, they just want to do QC. The most accurate is actually these two, LM8 and CL300. And lens analyzer like SOLOS, I wouldn't really recommend for edging. So the main, even from Japan, they do say that we recommend SOLOS for upselling lenses compared to doing it as a QC. So try to sell both instead of just one. Okay, so the main difference within these two, lens meter and lens analyzer, so high reliability for central ophthalmic lenses. So that means your glasses power, if you just want to measure the central accuracy, central power, lens meter like LM8 and CL300 is more reliable and repeatable compared to lens analyzer. Lens analyzer is better in terms of broad power checkup. So it's not just central power, it covers the peripheral power as well. So this is another info that you won't get with a lens meter. So it's really powerful, but unless you don't know what to talk about, it can be overwhelming sometimes. So as I said before, it's good for edging, for lens meter, ideal for edging, cutting lens. For lens meter like CL300, it's possible to detect multifocal compared to single vision. Single vision lens is like glasses for nearsightedness only. Multifocal or progressive lens is a multiple focal lens that has nearsightedness and also cover reading power as well. Okay, so for lens meter, it highly dependent on operator, especially for LMA. And for CL300, it's possible to do UV filtration percentage as well. So you can detect, is it UV filtering or not? And then we have lens analyzer, which is the SOLOS or SOLOS light. So we have two now. SOLOS have spectrometer. SOLOS light doesn't have spectrometer. So the main features you get from SOLOS is they give the lens property. It covers in terms of power, distortion, prism, what kind of behavior the eye experience when they use certain lens. So with the prism, you can actually know whether it's adaptability of the eyes. Is it better? Is it hard to adapt to the glasses? All this is possible with the SOLOS. So a lot of the time when you check multifocal, so you can check the power. Power is fine, position is fine, but the patient will complain that it's not comfortable. It's not really. It feels very hard to use, even though they say it's clear. So things like this, it's possible to see from Solos. And if let's say lens meter, you can just check power. Or power is correct. Why it's not comfortable? You don't have anything to defend against the clients or patients. So that's one powerful tool. It's for controlling expectation, and also it's uh, to give you more information and to upsell what kind of lens. Maybe you're using very good lens before, you can try to convert a better lens or the same tier of lens. Okay, so that's how to talk about lens analyzing instead of lens meter. Try to focus on the things that impossible to get with the lens meter, things like prism, not central prism throughout the lens. It will affect multifocal. Okay. So, and then it also have spectrometer. So it will check the frequency that the lens, what kind of frequency can pass through certain lens. Especially if, let's say, you have sunglasses, it's possible to check what kind of frequency passes through, what frequency doesn't. Okay. So for your basic understanding, we have this basic types of lens. We have single vision lens, which has just one focal point. Bifocal, as the name says, is two. And trifocal, usually we don't use this lens anymore. And we have progressive, multifocal, or variable focal. So these three is the same. So it has multiple progressive focal points. So this is the most expensive lens you can get. It can cost from $200 to I don't know, $200 to $1,000, depending on the brand and design. So usually it's either this or this on our modern day, but some still use bifocal, but not a lot anymore. So either these two. Okay. So this is how it looks like. This is modern day lens. So this is bifocal, trifocal. This is actually single vision, and it can also be a progressive lens. So this is a myopia control lens, which would have a bit difficulty if you use SOLOS because it cannot detect this small uh, power difference. Okay, so the main difference with the LM8 and CL300, LM8 is fully manual, so it's highly technical. You need to know how to transpose. Transpose, one example is here. So you get one area this power, one area this power. You need to combine the power yourself to get this. So this is manually. So not a lot of people really knows how to do this. So if you want to sell this, usually manufacturer really like it because they have very highly skilled edger. So, and also usually when they have high skill operators, you will get a very accurate power as well. So this is recommended if, let's say, the manufacturer is asking, you can try recommend LME. CL300 mostly we recommend for shops owner, retail shop. They can actually get it easier because it's automated as well. Just put the lens and you can detect the power. So not that hard. You can detect either progressive, single vision, or bifocal as well. It's very ideal for if you want to do lens edging and also QC. A lot of the people who do edging prefer this type of lens method. Okay, so basically you can check and get this kind of power when you put the lens in instead of two different lenses. Okay, so SOLOS and CL300 similarity. So we have LCD touchscreen, both is touchscreen. You can detect lenses as well. It shows the power for central power, prism, and also PD measurement. So it's possible with the CL300, but only central position, UV detection, connectivity as well. So this is similarities, but then that's beside that, you have a lot of features that it's not possible to get in a CL300, which is the distortion map. Not just the distortion map, we have the prism mapping as well. We have spherical mapping as well. And also, you have a spectrometer, so you can get different frequency filtration. There's an automatic lens marking. It will do it for you. It also is a Wi-Fi able instruments, and you can actually export the PDF to a PC through Wi-Fi. Very convenient machine. So SOLOS use Hartmann check sensor, which is aberrometry, to actually get points. So we have 180 data points, and it will actually measure each point. So this is how the SOLOS get the overall power for the whole lens. Okay. So SOLOS. So this is one of the map that you can get. So this is a progressive lens. So you can see here multiple mapping. So you know what kind of distortion. So cylinder or distortion is actually the same thing. So if let's say it shows cylinder or distortion, it actually signifies, is there any unwanted astigmatism on the other areas? So the center here doesn't have distortion, and the edge here have a lot of distortion, 2.5. So there's a lot of difference between the central portion and the side. Okay. So beside that, it also shows the prism mapping as well. So you know zero prism at the center, and also each line will be represented with the scale at the side here. So usually uh, prism distortion like this will affect how well the patient can adapt to the glasses. So the higher the prism, it will affect how long they need to wear. And sometimes it can lead to exotropy or exophoric or isophoric because of the stimulation from the prism as well. So sometimes prism is very important, especially if, let's say, the PD, pupillary diameter, is off. It will touch on a position, for example, here. So the center of the lens is here. When you have a wrong PD on the lens, it will switch to here, which is the green color. It's 250. So when the eye have a 2.5 diopter prism, it will actually feel very uncomfortable because the eye have to push back against the 2.5 prism direction. Okay. It does have the PD as well. And also this is a spectrometer. I will show you if, let's say, it's very low, that means it's filtering. If it's very high, that means it's passed, it's transferring through the lens. So over here, we can see the measurement here. 0 UV is passing through. 45% of blue light is passing through, but 73 visible light is gone through. So most probably this is actually a sunglass because 75% visible light is filtered. CIE is actually the color coding or color coordinate. So you can actually give this color coordinate to manufacturer and they will get the color code for you. So this is another function. Okay. But why do we still need the CL300? I would say it's more ease of use. It's faster overall. If I have a CL300 in front of me and a SOLOS, I could do faster measurement with a CL300 because SOLOS is fully automated. And also central accuracy is better in CL300 compared to SOLOS, especially if, let's say, you have very minor difference like 0.25. Cylinder is actually very hard for SOLOS to compare. Okay, so and also it's possible for CL300 to measure contact lenses, not for SOLOS. Okay, so that's it for lens. For now, between LM8, CL300, and SOLOS, do you guys have any question before I start the demonstration with our patient, with our customer here? Yeah, Tian, Nên Lối.
Ok, có câu hỏi gì không hai bạn?
Am I going too fast?
Lợi em nghe em lấy lợi.
Em có. Có hiểu không? Có hỏi đi không?
Dạ, không ạ, không có câu hỏi ạ.
Tiên em có hỏi gì không Tiên?
Chưa, em đang cần cái sự vận hành máy.
Từ từ từng bước một Tiên ơi, mình phải hiểu cái bản chất đã, rồi sẽ đến cái vận hành. Nên là cứ bình tĩnh, từng bước một, mình có nhiều thiết bị lắm, không vội được. Ok ha, cho đi tiếp ha. Okay, go ahead, Isu.
Okay.
Thank you.
Okay.
Yeah.
Sure. Okay. Yeah, let me just switch to my phone.
So you are customer side now?
Yeah, yeah.
Oh.
Oh.
Oh, it's optical stuff.
Yeah, yeah. The main, I would say, in terms of function and benefit, anyone who actually sells lenses will have the most benefit from Sonos. So it doesn't matter whether it's a hospital or optical store, anyone that are selling glasses, please recommend. Let's just show you guys this. So they have a customer right now. So first of all, he's going to close everything first. I'll just show you what you have to do with the Solos. Okay. So first of all, make sure you have to turn on. Switch is there. You have to push, hold a little bit, 1 second, and let go. So you just cannot tap it. You need to hold it slightly. Okay, then it will switch on. So we have a lot of glasses here.
Last time you told me that we need prepare about 2 glasses, right?
Yes, one single vision, one multifocal. So I have three right now. So I have two multifocal and one single vision. I can compare this and this later. So we can show what's the main difference between a good lens and a slightly cheap lens. I'm taking care of these glasses because this is mine.
Expensive one.
Okay. So it's quite easy to do. There are a couple of things that you have to be careful is something like this, curved glasses, very small glasses, this big. So if let's say it's curved like this, make sure the nose pad is pushing through. Okay, going like that. And make sure it's quite stable to pushing. Okay, it's quite stable. So the thing you have to look for is this too. Sometimes when the frame is too curved, it becomes like this. So the glasses need to move right and left. So it will push the glasses off. Sometimes it will pop off because it's moving. So example is that. So press here to start. So you can see here. So if let's say it's too curved, it will actually push because I'm not worried because this is quite large frame. But sometimes if it's too curved, it will actually just fling and like slingshot the glasses off. So be careful. Okay, so that's how actually, you want to start the measurement. Just make sure it's stable, then press this button. Okay, done. So it takes roughly around, this is just lens meter. If you notice here, this is just measuring the power. It's not measuring the spectrometer. So if just the lens meter, it takes roughly around, I would say 20 seconds. So it takes a while. If let's say I have a CL300 beside me here, it's just gonna take me 5 seconds. So that's the downside of using fully automated. It takes a while to get the power. Okay. So once you have this, so this is actually the distortion map. So try to open this up. First of all, just go to spherical map. So we have this power. So how to explain this? I think it's easier if I zoom in. You press here, you can zoom in the lens. So the top part here is not it. This is the SOLOS distance referral point. So DRP. And this is the near referral point, NRP. This is based on the highest minus power. This is the highest plus power. Okay, just absorb that first. Sometimes certain lens design would have a very large zero power. So my classes here is zero power. And over here is the highest plus 1.59. So it will get the maximum plus at the bottom for near, maximum minus at the top here. So that's why you get very high like this. So my glasses is actually not this high. It's actually slightly lower. That's the distance point by the manufacturer. It's just because the distance area is quite big, so it assume that it is the highest. So sometimes patient would actually question, the client would question, why it's not exactly the same as the marking of the multifocal? It's because of this concept. So the higher the plus, the minus, the higher the minus power, which is zero, it will mark as distant power. Sometimes manufacturer actually mark here slightly lower. It can happen. So you need to actually remind them this is the design of the glasses. And the Solos cannot detect exactly as the manufacturer. So that's why the position of the distance is slightly different than the manufacturer reference. So sometimes this will happen, especially if, let's say, my glasses, this is not entirely correct. It's just the distant area is very big, so it assumes very high, but it's still okay. So if, let's say, the area we can use, so zero is the middle here, it's quite big, and this color purple is actually here, 450 here, yeah, here. So each dot here, if you notice as the dot, one the distance between the dot is 2 mm. So that means from here, so from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 gap. So 18 mm. So my glasses here, 18 mm is distant area. So it's almost like 1/3 of the glasses. It's quite big. So that's how you actually apply the distance here and the size of it on the glasses. Yeah. Do you guys understand that?
Okay.
It's a bit it's very technical.
Yeah, but I can see that is they will take the highest minus for the
Yes,
far
this one.
distance, right? Yeah.
Yes. So the
And
SOLOS just assume the highest minus is the distant power. But some manufacturer actually adjust slightly. So sometimes it's a bit lower than what SOLOS detect.
Okay,
It
thì
can happen.
let me translate to Lợi a little bit. Okay.
Please translate.
Thì là cái SOLOS ấy, nó sẽ đo, đây là cái phân tích cái độ trên cái kính ấy Lợi. Thì nó sẽ đo cái độ ở trên kính, thì cái vùng cái màu bằng không ấy, cái vùng mà màu cam cam ở trên cùng ấy là cái vùng mà cái độ cận của nó, cái độ minus, tức là cái độ trừ ấy, nó thấp nhất. Thì ở đây trong cái kính này là độ trừ nó bằng không. Thì SOLOS nó sẽ đánh cái ô tròn và nó nói đấy là cái vùng nhìn xa của bệnh nhân nhé. Tuy nhiên là một số cái kính ấy, nó design là cái vùng nhìn xa nó sẽ ở dưới cái ô tròn đấy một xíu. Thì SOLOS nó không biết được là mỗi cái hiệu kính thì nó sẽ giống như kiểu là nó sẽ marking cái vùng nhìn xa của nó là ở chỗ nào, mà nó chỉ đơn giản là nó chỉ đo được cái độ kính ở cái vùng đấy thôi. Thì đấy là lý do mà cái marking của cái SOLOS ấy, có thể nó hơi lệch so với cả cái thiết kế của cái tròng kính đấy. Thì giải thích cho khách hàng là SOLOS đơn giản nó chỉ đo power và nó lấy cái chỗ mà power minus thấp nhất ấy, nó coi đấy là cái vùng nhìn xa. Và ngược lại ở dưới thì là cái độ plus ấy, cái độ cộng ấy là lớn nhất, thì nó coi đấy là cái vùng nhìn gần. Và nó cũng có thể lệch so với cái thiết kế của cái tròng kính. Thì để mà mình giải thích cho khách hàng thôi, thì anh ấy cố giải thích cho mình là như vậy. Lợi hiểu với anh không?
Dạ vâng ạ.
Cái này nó cũng hơi technical về cái tròng kính ấy, thì có gì mình sẽ bàn luận thêm ở trong nhóm. Nhưng mà nếu mà cái đoạn nào mà anh thấy nó khó thì anh sẽ dịch. Đào với cả chị Hương thấy mà em có làm nói gì sai thì correct hộ anh nhé. Cái này nó cũng hơi phức tạp. Okay, go ahead, Isu.
Okay. So I also take I'm just gonna show you a different glasses. So I just test this glasses just now. So this one, if you notice, if I zoom in, so this area is actually a bit lower. This is because the power is higher. So the area for distance is smaller and it can detect a bit lower compared to my glasses just now. So my glasses have a very big distance area. So that's why SOLOS will detect the highest end. This one, because the power is slightly higher than what I have just now, so it detects a bit lower. So that's two factors. One, the power is higher, so it gave a better distance referral point. Number two, the design of these glasses is very old design. So usually old design have a small distant area. So that's why you can detect better. So there's two factors that influence the distant area. Distance referral point.
Trong cái trường hợp này SOLOS sẽ đánh giá đúng cái độ nhìn xa của bệnh nhân ấy. Cái vùng nhìn xa bệnh nhân, bởi vì là có hai yếu tố. Yếu tố thứ nhất là cái kính này ấy, thì cái độ cận nó lớn hơn, tức là cái công suất nó lớn hơn. Và thứ hai nữa là cái thiết kế của cái kính này là thiết kế kiểu truyền thống, nên là cái vùng nhìn xa nó nhỏ. Đấy là lý do mà cái SOLOS nó đánh dấu đúng cái vị trí của cái vùng nhìn xa của cái kính. Okay, go ahead.
Okay. So another thing. Boleh pilih ruler tak? Boleh pinjam ruler tak? Boleh.
So this one connect to the computer by Wi-Fi, right?
This one I haven't connected yet, but it's possible to connect. So you can export the lens, export the report directly to the PC via Wi-Fi. Okay, so that's That's the point that we have for distance, and that's the near area. So you can actually see from here 0.75. So it's actually here. Yeah. So the area you can use for distance is from here until this purple color. So 1, 2, 3, 4, 5, 6, 7, 8. So 16. 16 mm. So a lot smaller than my glasses. So from the center point, just this much from the zero you can use. So it's quite small compared to my glasses just now. So this is considered a cheap multifocal. The distance area is quite small, and intermediate is even worse. So that's how to actually interpret this data. Because you see from the distortion, a good distortion is anything below 0.5. So 0.75 is considered higher distortion, and it will be noticeable for the patient.
So you mean that
how
anything lower than 0.5 is considered the distant area,
usable area.
usable for the distant area.
This one distortion actually shows all three: distance, near, and also intermediate. Intermediate usually would be small, but the border is actually this color. So this is the border. So anything between this 1, 2, 3. So 6 mm just for intermediate. It's very small. For reading is actually bigger. So 1, 2, 1, 2, 3, 4, 5, 6, 7. So 40, more or less. So
40.
this is a balance. Distance and near is balance design, but it's considered very hard design if you look at here. So about multifocal, you have to know two things. In terms of design, whether it's a uh, distant comfortable design or near comfortable design. So that's a basic understanding. So if let's say it emphasizes distance, most of the time intermediate and near would be smaller. So that means it's comfortable to use when you walk around, but when you do near work, it's not going to be comfortable. That's a basic understanding of a multifocal. And another factor is how close these two is together. If the near area is closer to the distant area, basically we're going to squish everything together. So when you squish everything together, the distortion becomes more. So two things: the corridor, we call it corridor, the distance between the gap between distance and near. How big is the corridor? 14 mm is a big corridor, 11 mm is a small corridor. So the smaller the corridor, the more distortion. So how do we actually measure that? So we can measure it from distance, referral point, which is here, and maximum ADD. So ADD is 2 here. So how we measure? We want 2 mm. 2 mm starts from here, 13 mm, distance 0.5. So here. So roughly around 0.5. 0.5 minus 13 is 12. 12.5. So the corridor is 12.5. Is it too fast for you guys? Do you get it? Can you actually see what I showed just now?
Yeah, I can see. So I just want to explain to Lloyd a little bit. Okay.
Yeah. So I'm just gonna explain again. Okay, so how you want to determine the corridor of the multifocal, how the distance within these two is getting the maximum EDD, which is 200, the reading power. 200 is here. It's a bit glary.
Yeah.
Yeah, it's blur.
Yeah, it's cloud.
This one
right?
can
Okay.
see. Yeah, this one can see.
Okay, so
2 mm.
200, you just go up.
Mm.
What is the starting point of maximum reading power? So it's somewhere around here. So this is 13 mm.
Mm.
So this graph is in mm. This is the ADD. So ADD, you can look here. ADD minus plus 2. You go up because this area is all plus 2.
Mm.
So you mark here. Maximum plus 2 is here. It's on 13 mm. So you mark here 13 mm. And then the distance power is 0.5. So 0.5 is somewhere.
So this distance here is the spherical one, right?
Oh, yeah. This is distortion. Spherical.
Okay.
But but this is the average. You don't really need to change or anything. So this is from 0 ADD. You just measure the ADD instead of the spherical power. So 0 is the distance power now. So you can measure from here. So this is 1.25 mm. We can just get 1.5 easier. So 1.5 minus 13 just now.
So it should be 12.5.
So 11.5. 11.5. Yeah, 11.5. Sorry, yeah. So
No,
11.5
that distance
is the corridor.
The corridor is bigger is better, right? Smaller is not good.
Okay.
Is that
correct
right?
if you want to eliminate distortion.
Okay. So
But
let me explain.
In terms of
explain a little bit.
functionality, it's different. Okay,
Okay.
please explain first.
Lợi ơi, can you come back to the screen? Okay. Thì ở đây trên cái dòng ở bên trái á, cái dòng spherical ấy, mình sẽ nhìn thấy một cái là cái độ cầu nhé. Okay. Cái độ cầu là trừ 0.5 ở bên tay trái ấy. Lợi có nhìn thấy không? S gì ấy? Spherical ấy. Em có nhìn thấy không Lợi?
Spherical.
Và cái độ cộng ấy là độ nhìn gần ấy, độ cầu là cái độ nhìn xa nhé. Nhưng mà bệnh nhân này cận 0.5 đúng không? Thì nhìn xa, độ nhìn xa của họ là trừ 0.5 diop. Thế còn cái độ cộng SADD á, là cái để cho họ nhìn gần, thì ở đây họ S là 2. Thì cái cách mà anh ấy nói cái corridor, tức là cái khoảng cách từ cái chỗ mà cái độ nhìn gần đến cái chỗ mà cái độ nhìn xa á, thì anh ấy dùng cái biểu đồ ở bên tay phải á. Tức là khi mà cái độ ất là 2 thì anh ấy sẽ gióng từ cái trục 2 là cái trục hoành á lên, thì nó sẽ cắt vào một cái đường màu xanh đúng không, của cái kính. Thì cái đường màu xanh ấy gióng ngang sang thì nó sẽ là 13 mm nha. Thế còn cái độ trừ của cái kính là 0.5 ấy thì anh sẽ gióng cái gần như không ấy, từ 0 ra đấy, 0.5 ra ấy, thì nó sẽ ra là 1.5. Thì bây giờ người ta sẽ lấy là 13.5, 13 đi ha, trừ đi 1.5, tức là cái corridor của nó sẽ là 11.5. Tức là từ cái điểm nhìn gần đến cái điểm nhìn xa của cái kính này là 11.5. Thì anh có nói đến cái chuyện là với một cái kính đa tròng ấy, thì cái khoảng cách corridor này mà nó gần ấy, thì nó sẽ gây ra rất là nhiều những cái nhiễu loạn. Nó xa thì nó sẽ dễ hơn cho bệnh nhân, còn nếu mà nó gần, tức là gì, giữa độ cộng và độ trừ nó gần nhau quá thì cái sự thay đổi ở giữa nó rất là lớn, nên nó sẽ gây ra một cái rất là khó chịu cho bệnh nhân. Đấy, thì mình hiểu được cái cách mà người ta cái máy nó đo là một, thứ hai nữa là cái cách mà mình nhìn ở trên này. Thì nếu mà nhìn ở trên này thì nó có những cái dấu chấm nho nhỏ ở trong cái tròng kính nhé, thì giữa hai cái dấu chấm đấy là cách nhau 2 mm nhé. Thì mình nhớ là có thể đếm cái số ô ở trên đấy, mình biết là cái vùng màu vừa nãy anh ấy đếm ngang ấy, thì anh sẽ thấy là cái vùng nhìn gần ấy nó sẽ rơi vào khoảng tầm 8 cái chấm này, tức là 82 là 16 mm. Còn cái vùng nhìn xa chứ anh nhầm, cái vùng ở trên ấy là vùng nhìn xa thì nó sẽ rơi vào 16 mm. Thế còn cái vùng nhìn gần vừa nãy anh ấy đếm là khoảng 7 chấm, tức là 14 mm. Thế còn cái vùng mà trung tâm ở giữa là vùng nhìn trung gian á, trung gian là cái thị lực khoảng tầm 60 cm, tức là mình làm việc trên máy tính. Thì ở đây đếm là 1, 2, 3, 4, 5 gì đó, sẽ là khoảng tầm 8 đến 10 mm thôi, nó rất là nhỏ nhá. Thì cái vùng đấy là cái vùng hữu dụng của cái kính đa tròng này. Thế còn những cái ở ngoài cái vùng đấy là mình sẽ không nhìn thấy đâu. Ví dụ những cái vùng màu xanh ở hai cái ở hai bên ấy, thì mình sẽ không nhìn được, nhìn vào đấy sẽ không thấy cái gì cả, nó bị nhiễu loạn. Okay, go ahead, Isu. Thank you. Hi, Isu. You can
yes, yes.
continue. Yeah, you can continue.
Okay. So that one is terms of corridor. Okay. So beside that, I just want to show that you can actually pinpoint the area. So once you push, you just tap here, you can actually see the spherical power, the cylinder power, and also the axis. So this is actually showing the area at this position and which power is it. So you can see here, the power is off by a lot, -1 astigmatism at the side. So most probably you cannot use this area. And also, one more thing I just want to show is the HP. So this is horizontal prism, 0.46. I is base in, so roughly 0.5 prism base in. So this is actually would affect how comfortable the glasses is. So we have base down and also base up for vertical prism. So another way to actually see is going to prism. So the basic understanding is the closer to 0, the more comfortable on the eyes. So if you notice here, for distance and near, most of the time the eye would be somewhere around here, between distance and near. So this line. But as I say, there's no 0 properly inside here. Do you guys notice that?
Yeah.
So this line here, there's no 0 prism. That means the eye would always have prism when they move from distance to near. So this is a very bad multifocal. It's not easy to adapt. And if you tap here, so the prism is 1 base down. 1 base down actually help a little bit your eyes to go down. So if let's say you have prism base down, that means what about here? Oh, super weird. Multifocal. So near we want more base down, but they put more base down on the intermediate. So base down actually helps the eye to just move, not a lot of movement, then you can actually use that area. So instead of the eye move slowly from this point to this point, if you have prism base down, even your eyes are located here, it will automatically go down here. So that's how prism works. It actually helps the eye to move lower. But this design put lesser base down here, but higher base down here. So it makes it easier at first and then become hard to go down here. That means it's not really comfortable near. Maybe intermediate is slightly more comfortable. So this is basic optics. So I know it's a bit hard to understand.
But one question. So it means
Yes.
that the prism is as close to 0 is better, right?
Okay. In general, correct. If you don't have 0 unit, no prism between here and here, you consider it a good. It's comfortable to wear. But there are certain orientation of prisms. For example, base down here, help help the eye to go. If let's say we're talking about reading, if you put the prism base down on the lens at the bottom here, it helps to move the eye from top to bottom. So the movement would be compensated with the prism base down. Is that easy to understand? The prism
It's
basically
a little
helps.
bit difficult.
The prism basically forces the eye to move in certain ways. So prism down, it makes it easier for the eye to look down.
I see.
Prism
So
base
now
in,
now now is a vertical one.
yes, down is a vertical. So if let's say you talk about horizontal, if it's a prism base in, it makes the eye easier to converge.
Converse.
Converge, yes.
Converse.
Because you're converging from straight, and when you read something, it's converging, right? When you put base in, it's easier for the eyes to converge. So it helps.
Okay, I think it's quite difficult here,
Yes.
but I think I understand a little bit. But
So
I'm
prism
not sure.
can work both ways. It's either helping the eye to move towards certain direction, or it can go the other way around and makes it harder for you to actually go to certain direction. If here is a base up, then it's very hard for the eye. It needs to move more downward to actually go to certain direction. So if you look at near and the prism value is prism base up, it actually make it worse for the eye to go down.
So when it's up and when it's down?
It depends on the multifocal design.
So I mean that if the number here is 0.48, right? For the vertical
if like
prism.
this,
So it's up or
0.4
down?
base down, this is base down, and 0.36 base in. But if you ask me, any prism less than one prism diopter doesn't really affect the eye that much. But like this, prism 1.4, then it definitely help the eye to go down. But the 8 reduces from middle to near, basically doesn't help anymore. So there's a difference between top and bottom. But if let's say I put back my glasses, you can see a difference in terms of prism pattern.
So do you have any material document that we can research and understand more about the prism?
You
So I think we
need
can
to
understand
go
better the
through
training.
optics. In terms of prism, it's physics, I think. Why do you learn this?
Or later I have to ask I have to ask some doctor or some
I can try
optometrist.
and look through certain things, but it's a foundation for optics, bio optics.
So I can understand more, but now it's quite difficult.
That's the reason why I'm talking about SOLOS, not like Laura. Okay. So you can see the difference here. This is my glasses just now. So if I go in, please up. Yeah, from 0. So 0 is okay at the top here, but once I go to the bottom, the reading area stops somewhere around here. There's a base out, negligible, but there's a base up. So that means when I go down, it actually forced my eye to don't go down, do not go more than certain period of line. So it stops my eye from moving downwards. Okay? Because there's a base up here. And it's impossible for my eye to go over here. So it's going to be very uncomfortable. So the area I can use is smaller. So it doesn't encourage my eyes to go slower. So this is okay, very comfortable for distance, but near, only up until here is comfortable. When you go lower, it becomes uncomfortable. Okay.
So I think I just understand a little bit, but I have to translate to learn.
Okay.
some general thing, or I
I'll
think
try to
for
get. I think the presentation by Doctor uh, Hu from Korea about SOLOS is good. Do you have access to that? Tokyo University.
Yes, but I have to check because
That's
yeah, I
a
have to check.
very good, but it's already borderline
SOLOS, right?
very technical. So not everyone would want to know about that.
Yeah. Okay, but
But
it's good. It's
if
good to
let's
know.
say,
It's good
if
to
let's
know.
say you know about this, it's easier for you to upsell.
Right.
You know it's
So
comfortable somewhere around
so we
here, so you can
understand
switch
what
to
is
different.
a good multifocal, what is a not very good
Yes. You
multifocal. So
you
that's why
you
we
just
can
need to
upgrade.
know generally what is a comfortable multifocal in certain area. Is it comfortable for distance? Is it comfortable for near? Then it becomes easier for them to apply on certain glasses if you understand. So that's the reason why I need to touch about this. If you don't really know how to explain, it's hard for the operator to apply to the type of multifocal because there's thousands of multifocals. So they need to understand what they're looking at first, and then they can compare which is better.
I can see the Dr. Du Wan Lee lecture. Okay, so
Yes, that's a
we will
very
enroll.
good explanation about SOLOS regarding what is a good multifocal and what points you need to focus on. That's a very good lecture.
Okay, we will enroll the
But the thing that I talk about, the
course.
prism, base up, base down, I don't think he talks about that lah.
I see.
But he talks about closer to zero have a more comfortable multifocal.
Good.
Okay. So make sure you go through that as well. It's very good. It will show you each map and what you want, what you expect from certain map.
Got it.
Okay.
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 Okay. Như vậy thì để nói nhanh, sorry I talk a little
Yeah,
bit.
please translate. Yeah.
Để nói nhanh với Lợi chút xíu là cái này nó liên quan đến mấy cái lăng kính thì nó cũng khá là phức tạp. Nhưng mà tuy nhiên ấy thì là ở cái prism ấy thì nó sẽ có hai cái, một cái là horizontal, một cái là vertical. Thì horizontal ấy thì nó sẽ có xu hướng là cái mắt của mình nó quy tụ lại giống kiểu mắt lác ấy. Tức là quy tụ lại hay là nó là converse, tức là nó đi di chuyển theo chiều ngang. Thế còn cái vertical ấy thì nó sẽ là di chuyển theo chiều dọc. Như anh ấy nói, nếu mà trong trường hợp mà nó là cái base up chẳng hạn, ví dụ vertical nó là cái base up, tức là khi mình di chuyển đến cái điểm đấy thì mắt của mình nó sẽ có xu hướng là kéo mình ngược lại, tức là mình không nhìn được quá cái điểm đấy nữa. Đấy, thì nếu như mà cái lăng kính ở đấy nó lớn, nó cách xa không ấy, thì mình di chuyển mắt đến đấy nó sẽ kéo mình ngược lại, nó không cho mình di chuyển nữa. Vì nếu mình cố mình di chuyển cái mắt xuống dưới cái vùng kính đấy nữa thì nó sẽ gây ra rất là chóng mặt. Cái này tương đối phức tạp, bản thân anh cũng chưa hiểu lắm đâu, thì anh nghĩ là mình sẽ cần phải đọc thêm và học thêm trên cái online nữa. Thì bây giờ mình tạm thời là mình biết cái cách người ta sử dụng cái máy cũng như là những cái cách người ta phân tích các cái vùng là như vậy, rồi mình sẽ tìm hiểu thêm. Okay, Izu.
Yeah. Is it okay? We already passed the time for you guys. You guys are still okay to go through?
Yeah, so Tien had the training with the hospital, so he left already. So
okay. The one that's
for the other
available right now. Okay. So I'll just go through. I think in terms of details of the map, you can go through on the Dr. Lee lecture. Definitely will explain a lot. They also explain how to see the corridor as well. So it covers that as well. But I'm just gonna show you the other function that I think is really important when you do demo. So just go to setting here. Setting, go to maintenance. So very important, to actually show this packing mode, measurement area clean, and calibration adjust. So this is what we encourage each time. Okay, so I think we are ready for.
Yeah, so
Kong, I think I'm just gonna invite the shop owner to join us as well. So just give me a sec. You're
I
already
see.
ready. Mhm.
Okay.
Okay ke? Nak join? Okay ke nak join?
boleh
Eh,
sekejap kena
pernah
masuk.
tengok post ni.
Pernah tengok ya?
Nah, pernah pakai.
Pernah pakai ya? You continue?
Yeah.
You continue? Yeah.
Tengah borak lagi. Okay, let me just go through a bit. So the setting is now. One thing that I just want to talk about, if let's say you want to move the machine, you have to make sure that the customer know how to pack packing mode. Because if you go down, so here it moves a lot here.
Okay.
So if you didn't put into pack mode, it will not hide this movable parts. There's a chance it will like unalign the position. So be careful. So pack mode will just keep this movable area inside, so it's easier for the machine to be moved. So another thing is measurement area. Guys, ready? Can.
Yeah,
Yeah. Ready? You sure? Wanna join us? Không gas. Không gas.
Anh ấy Lợi có nói đến cái việc là khi mình di chuyển cái máy ấy, thì mình phải để vào cái chỗ packing mode ấy, để cho mấy cái bộ phận mà nó chuyển động nhiều ấy nó sẽ thu gọn lại. Còn nếu mà mình không để chuyển
Rồi,
vào trong
I
setting thành cái
introduce myself. I'm Izul.
Izul, IZUL.
Isaac, ZUL.
IZUL.
Yeah.
thành cái
Izul.
packing mode ấy thì là nó sẽ dễ hỏng nhá. Nên là cái này cũng là cái lưu ý lúc mình đi demo đấy, vì mình sắp có cái máy
Have
solo
you seen
demo.
her before?
Em còn nghe em Lợi?
Em có.
Thì khi mà anh nói thì tương tác để cho anh biết là em còn đang nghe nhé.
Vâng ạ.
Cứ mạnh dạn mà tương tác thôi em. Hi Izu.
Yeah, yes.
Okay.
You're
So
gonna-
we continue,
Yeah.
right?
Yeah.
Wait for
We're gonna
something?
continue. Sure. I'm
Okay.
just gonna show how to actually use the packing mode, area clean, and calibration adjust.
I see.
Okay. So packing mode, and you press here, it will start to move and keep the machine inside, the movable part inside. So very important. Each time you want to move the machine, this is kept and secure. So then on again. So another thing is cleaning the area because it's very sensitive. The point of measurement is actually on each dot here. If let's say there's debris here, it will affect in terms of accuracy as well.
Okay. So do we need to clean it or
Yes. Please clean it once a week.
once a week? Oh.
Once a week. But it's quite easy. Just make sure you have a cloth.
Mm.
So I'm showing how to actually clean. So you need to clean this once a week.
Mm.
Okay.
So the measurement, the dot here is the point of measurement. If let's say you,
Millimeters that you talk.
yeah. So this is called Hartmann and Shack aberrometry.
Okay.
So you can actually get each point per point for lens power from the dot here. So if this point is not clear, it will affect the accuracy of your measurement. So how to actually go there? Go to setting, go to maintenance, and then press measurement area clean, move to clean. You'll just get glasses, cloth.
Mm.
You can actually just
You
wipe.
need to lift up the ring? No.
No.
It's just,
Okay.
So just this one. Okay, done.
Mesti no spek kau lah.
So it's just like that, quite easy.
Ini untuk cuci lah.
Ini untuk cuci. Seminggu sekali. So kalau nak gerakkan dia, I cannot speak Malay. If you want to move the machine, make sure you press packing mode here. Then everything goes in. It secure the machine. So if let's say, because this is quite sensitive, the movable part, sometimes it will unalign the machine and it becomes a problem.
So there's two calibration every week or so.
This one, no need. Just if let's say you want to move the machine back to there, you can just press packing mode. It will just pack the movable part inside. So it becomes more secure to move. Yeah. And last is calibration adjust. This one, I think for the period of you doing the demo here, no need to do. So just use that, no problem. So this one we will do. So calibration adjust needs a calibration lens. So later on, when you get the machine, you will get it together. Okay, you have to do it. If not mistaken, is once a month. But it's just checking the measurement, not really adjusting the calibration. Adjusting calibration, you need to call for engineers. Okay, so that's basically how to actually do maintenance for the machine. Okay, I'm just going to show you how to actually test. Just go in, put it in like this. So be careful if it's a curved frame like mine, especially curved and very small, sometimes it can just pop up like that because it will move right and left. It will just hit the middle here. So be careful. If let's say you have a curve, rimless glasses, please hold on to the side here. To start, press and hold. Especially rimless. Quite dangerous. So if it's a kid's glasses also, it will hit the side. So be careful. So if you find that it's too small for this machine, don't put it inside. Okay. So everything is automated, right and left. There's two modes here. You can do lens meter, which is the power. Second mode is the spectrometer. So you can do both. Well, this one I just put lens meter. It's easier. It's faster as well. Spectrometer is actually to see certain frequency, which frequency passes through the lens. So blue light, UV light, red, green, anything you want, it's there. Unless it's infrared lah, and non-visible light, it's impossible to check with the machine. Okay. Okay, so you already have a template here. So this scale shows the power. So we look at the map first. We put in spherical map. So this is a spherical power from top to bottom. Top to bottom. This is a scale. 0 is no power difference because I'm not wearing any power lah. 0 power. But there's a reading power at the bottom here, plus 1.5.
Oh, press bio.
Really press bio lah. I just put extra. I don't want to buy again. Because I know I can put extra, that's why lah. Yeah, it's expensive. Okay, so top and bottom, Zero power at the top and bottom. So our machine detect distance as the most minus power. Detect ADD, the most plus power. That's the basis of the machine.
Okay.
So sometimes you
It
get
tells
like this lah.
but two different designs.
Hmm. It's almost the same lah. It's just if you see it skewered like that, it's the astig.
Okay, yeah.
Yeah.
Okay.
Mm.
Right.
So if you have higher astig, you have a skewer in terms of the symmetricality.
So
So
if we put in the bifocal inside,
it can detect bifocal.
show, yeah.
Bifocal, single vision cannot
Okay.
just cannot check for myopia control lens.
Those lens with the dots are
With the dots, dims or anything like that, because it will just assume it's a single vision. It's too small to detect. Okay, so degressive is actually of essence. Okay, so spherical, so you have the highest, lowest power. So if let's say the area is too big, the distance is wide, super wide like this, it just detect the highest point now. So this is not actually the engraving of the glasses. It's not exactly the same. So it just depends on the power of the lens it detects. Okay. Then you have distortion. Distortion is unwanted astigmatism.
So the more red, in this case, the more red the better.
Correct.
But why does it say power? Purple is 0.7.
Purple is zero lah. Distortion. It will just check unwanted astig. So red is zero, but acceptable distortion is 0.5. Anything less than 0.75. So 0.75 is a noticeable distortion. So there's a point per point power as well. So 0.75 is actually okay lah. It's quite big. It's huge lah sebenarnya. So from here to here, so you have the area from 1, 2, 3, 4, 5, 6, 7,
14 mm.
14 mm.
14 mm.
So I can use 14 mm here lah.
With most very minimal distortion.
Almost zero distortion lah basically. Then more than 14, it becomes distorted slightly. So this is quite good lah. Quite good lah, zero power. So when you go further down, it's basically similar in terms of size. Distance is this big, intermediate is more or less just slightly smaller. Reading is the same as distance. So it's a balanced design, not really emphasizing on distance or near. So we can see from the distortion map here, whether it's a balanced design, not distance centric, not near centric. Okay. So you can also pinpoint if let's say you have a wrong PD, you can actually just pinpoint which area is the power at or your PD, the wrong PD and where's the actual power at lah. So you can actually see from there as well.
So you point this way. But how come there's a dot? There's a darker dot there.
But that's just the center of there's a big dot there as well.
Okay.
The center of the Hartmann
It
check.
happens to have a marker. If you have a marker that
Dot there. Does it affect?
doesn't appear.
It doesn't appear. But it depends on how thick is the dot lah. You already put the engraving there lah.
Yeah. So you just sort of guess.
From because the measurement is one thing is the 2 mm, the another is here. How you actually read from here. So this is the ADD, and this is the length in mm. So you can actually start from 0 ADD, which is you can actually start from 0 ADD, which is distant power, right? 0 ADD is distant power lah kan?
Yeah.
And maximum ADD 1.5 just now. So from here, what is 0 is somewhere 22.75, and the reading area is somewhere around 1.7.
So based on the height.
Yeah, this is actual height.
Actual height.
So
How come it's start from zero? Oh,
start from 0 lah. So the reference is still bottom and top. Near, oh sorry, this one is inverted because I changed.
But is this according to scale? No. Wait, hold on. Is it
Yeah,
exactly
yeah,
this
yeah.
way?
Oh no.
No. It's
This
just-
one is compressed. This one is actual. So this is based on his. Okay. So yeah, from 0, and then you measure from the maximum ADD lah. So you get the corridor. But this one is a bit hard because this area is too large to compare. So maybe it's not that accurate, but you know it's quite huge. That's why you cannot actually get the point of near and point of distance. And also the design lah. Okay. So, and then you go to prism. So prism distortion, if let's say you want to see the basic general understanding is 0 prism, that means no prism that is affecting the eye position. It's not moving up, down, left, right. And then when you introduce prism at the bottom here, this is for right eye. You can see here. So at the top, almost no prism. It's not affecting at all. Intermediate also, there's slight prism, but once you hit bottom here, there's a 1.3 base up. So it's actually making it harder for you to read at the bottom here. So from there, you can know that at the bottom of the lens, it's impossible to use. Then the most comfortable area is from here, lah, from the blue line. So that's how to actually see prism. So when you see the type of prism there is and how it affects how the shape of the prism, if let's say there's certain, if not mistaken, lifestyle V plus Hoya have like cylindrical prism like this. So the pink color start from here to here. It's like a pillar, diagonal. So Hoya would have that kind of design. So if you let's say we talk about Zeiss, the designs is slightly different. It doesn't have the pillar type. I think Zeiss you can see distance to intermediate is 0 prism, and then the bottom near it's not 0. So there's you can see from the type of design and the model as well. Vision Pro. Oh yeah. It's a huge frame as well.
Yeah. Only if you go any larger than this, would that be able to?
I think that's the reason why you have this area, the prism up, because it's actually unwanted area already, because it's big. So this is the effect if let's say the lens is bigger than the actual template. So you can see all this distortion. So that's why it's not recommended.
But the picture that shows it, this is round.
Yeah.
So the lens with the lens is a bit bigger. So to say, that means the whole thing will be. The actual spectacles will be actually bigger.
It should be bigger than this.
Yeah, bigger than
So
this,
it should be at the side here.
Okay.
Yeah. But it can be detect up to there only.
Circle that.
Yeah.
Okay.
Yeah, good question. Okay. So this is spherical equivalent. So this is the accumulation of astigmatism and spherical power. So this is just to see the pattern between distance and how fast is the power change. So for me, it's almost the same because my astig is very small.
Yeah. So we should be using cylinder and spherical.
This one, you have the general idea lah. So from distance to near, how it goes from top to bottom. Is it really rapid or it's not really that rapid? So this is the general information. But once you want to go in depth, you go to each of this map. But the usually
Prism alone is possible.
yeah, this is the prism map. So for me personally, if let's say we talk about multifocal, I would focus on either distortion and also prism. So this is how comfortable the glasses is. This is what kind of distortion we are looking at, the kind of image you can get from this.
So actually, we start off by using this wrap.
This is just whether you want to check both of the glasses or not. This is the function. If features. You want lens meter only, or you want spectrometer as well. And this one is automated marking. So if let's say you want to actually mark the multifocal, turn on, press start, it will start the marking process as well. But this one is a bit hard because it's almost end to end. This one will be nicer. That one is a long corridor chip multifocal.
Longer.
Hard design and a long corridor as well.
The price is very high.
Hmm. Okay, so that's a marking. This one you can actually induce prism as well. But usually for uncut lens, it's much better. Now you don't need it. So the marking is also different than typical marking you get from a lens meter. Lens meter is horizontal marking, right? So you just get the center point and horizontal mark. This one would actually mark at the astig axis.
Impossible to mark.
Oh, because it's at the end. Okay, this one. We use this one. Yeah, it's not really a multifocal. We'll try to use this one. So turn on marking. We'll start.
So if the lens is dirty, does it make a difference?
It does. Slightly, but that one is not that bad. If let's say it creates a layer on top, then definitely you have to clean it. Because Harman and Shad is point per point. So if let's say there's a smudge at the top, yeah, it scatters a bit more. It's not eating, is it? It's not touching. You're supposed to. Yeah, let me just. So if it doesn't touch, it's already dry. Huh? No, they're interested in the same machine as well. So might as well just do it together. Because they're in Vietnam. It's the iPad. We support iPad.
Not the 227. Mine is less than here.
Buat tadi ni. Kita tak tahu.
Oh, the last time I came, you all were like behind. And I'm asking when.
Oh, boom from the back.
4 years ago. So like we've always been here. It's just that we just consolidate into one. Always at this stage. There's always two shops running. So this one is different shop, there's different room. You can just came in this branch. No wonder. You were here with upon.
Yeah, I did my third.
What's that?
Like visit here, I don't know.
So, anything. Itulah, it's long. He comes in every because we need to jaga anak. So he comes every 2 weeks.
I bought it.
You know, like, that's cute. But if there's no customers who don't come to the make all appointments one day, then he comes in one day.
It's not really touching.
Correct.
Half, but not
The white dot.
complete.
Oh, the white dot.
So that's the white dot.
Oh,
That's the near.
Ah.
That's the distance. That's the axis.
that's like this. Oh, this way. Oh, interesting. Oh, but black and not black.
Mm.
That's this. You can see every camera.
So it should have, technically there should be 1, 2, 3. 1, 2, 3, 4.
Okay.
But I think this is a, yeah. We need to change the cartridge. This is a demo unit. But if let's say the frame is flat, it should have all the 4 dots for multifocal. So it shows the axis, the center point, the distance reference point, the near reference point. So it should have 4 dots. But this one just show 3. Should have one more in the middle, I think.
Okay. So one line. So 1, 2, 3, 4.
4.
One line.
No, just 1, 2, 3, distance and a stick, and then 1 dot for near. For EDD.
Okay, then this is what one more dot here.
Which one is the correct one? Wait. I don't know whether it's dirty or.
Okay.
Oh, yeah, this one. This one.
What is that?
Yeah, that one just now because just the bottom you know. Yeah. Yeah. So basically, it covers like that. Even unmarked lens, you can do adjustment. So sometimes when you do edging here.
Yeah, some.
Some. So if let's say you do edging, we adjust the axis first. We adjust the axis, then we put the lens, and then we adjust according to the axis we set, right? To actually edge. This one, you can set the axis on the machine. So it will dot for you.
Okay.
So instead of for you to adjust the lens yourself, it will detect first. Just let me know what axis you want. It will dot for you. It's easier to do edging, but I don't really recommend that. If you want to do edging, you
Even
should.
that single vision, right?
Oh.
Spherical and aspherical lenses did show the distortion inside.
Yeah.
It does too.
Definitely. Especially if, let's say, single vision, you have double aspheric, you have single aspheric, it does have different types of distortions. Not really distortion, both distortion a little bit, but prism is the obvious one.
Yeah, please.
Prismatic effect from the single vision as well, especially high power. So, and one more, you can check prism power from PD as well. For example, you adjust the height and PD. So you get the actual PD, you get the actual PD height, and then you can adjust accordingly to get the actual prism power. You notice if let's say you have prism.
For example, if high power, if the edging is done one high, one low, this would be able to
Adjust.
stop.
High, low, just get the center point, and then it will measure how much prism you are getting.
Okay.
It's actually easier compared to that.
Yeah.
That one you have to do manually. Then mark first and then move yourself again and make sure it's the more or less. Correct. So this one at least, for example,
This single vision?
this is single vision. Okay. But it's not, there's no prism inside. How often do you give prism?
But high power normally the rest sensitive is high. Sure the
But you give like prism with Zeiss lens or anything like that, or EC law?
usually it's like
EC law have marking for single vision prism?
No.
Oh. That's the reason why I use Zeiss for prisms. They mark as well.
where the
So it's easier for us to use that lens meter to confirm the prism. So if let's say Hoya and EC law, there's no marking, so it's just a custom made lens. So you don't know the pinpoint prism lah position.
where
Yeah. Okay.
these two lenses are different.
So it's a single vision, but you can see here the PD is off. So technically we can assume this as a there's a prism on the lens lah.
There's a different power altogether as well. Because
Yeah.
the ring different as well.
So if this is basically a wrong, it's very bad edging lah. But the power is very low.
But how do you tell how far what's the height difference on both sides?
6.5.
Means one side is 6.5 millimeters.
If you let's say you look at the prism point. So you can actually just adjust to 0. Then you get the prism on this side. One diopter. Base down prism.
Oh, that means you tell where the what prism is this.
Yeah,
this
but
point.
you need to have the PD, the actual patient PD, and also the PD height of the glasses lah.
What height is the point?
This one based on the left eye. So that's why based on the left eye is 0. Yeah.
Up or down? How do you tell this? In this case.
It's high. Up. It's base down. Sorry, base down. Base down.
Base down.
Base down. So I put 0 here. So it level the PD. So you have the same.
Yeah.
So then you get the base down.
Down. Okay.
Quite good lah. This one is a new update. It just updated a couple of months back, 2 months back. Before this, we can just do horizontally. Base in, base out only. Now we can do horizontal as well. So
Yeah. So
Quite easy,
what about horizontal in this case?
it's the same. Just adjust the PD. So this is both eye or one eye only lah. I need both. You want both eye or one eye?
So you can tell how much is my PD? Let's say
Yeah. If let's say you give both horizontal, both base in lah.
So it's 60 total. So
Mm.
it's 30.
You press OK.
That's fine.
Base in 0.75, 0.5. Quite convenient lah. I really like this after the update lah. Before this, it's impossible to get the vertical prism.
Okay. So the function that you say earlier, the lens meter, this is lens meter,
Spectrometer.
is for the mapping lah.
If you have a sample sunglass, you can try and don't get a expensive one with a mirror code lah. Don't get mirror code lah. Mirror code kalau calar nanti I nak cakap macam mana. Get something that is safe. Takut jugalah. We don't know, haven't tried, but I don't want to risk it. Mau gym glasses, glass okay kot. Tapi ada mirror code tak? Oh, they have a little bit. Can. But it's especially if let's say you have like the Oakley punya, kan diorang, they would really talk about the Oakley prism color tu. They have special color for certain situation. So you can actually see the frequency, the color code lah. If it's gray like this, I can assume it will just be general filtration lah. So maybe 70% here, all color. So this is blue, red, green lah. Yeah. Blue, red, green, right? Not green. 577 is yellow. 532 is green. So blue, green, red lah. Yeah. Hitam. So red, so you can see here lah. So visible light only 4%.
Very good.
Very dark lens.
So, visible light 4%. So you're talking about this is 90.
90. Yeah. Yeah. Saturation. So it's quite dark actually.
6%. Put on. So about 85.
So this one,
6%.
it filter a lot of blue and green light. Red light, it pass through more compared to blue and green.
Green face.
It should be more red base because the more red light is coming in.
But you say it feels okay. It feels still true. Yeah. Okay.
Yeah. It filter more blue and green light.
How do you tell that you like? Oh, see the same. How do you see the same?
Frequency. Yeah. 530 is green.
Yeah. Just,
810 is red.
we just know 570 is green. We just know.
We just go. 800 is red. Yeah. So this is red.
Something on difference.
We didn't check. We can try. We can check both. Can you have? Just make sure it's secure. Mm. So you have to be careful, especially curve frameless, very high risk. Try not to put it inside.
Or if the machine will push.
Yeah, if let's say you nasib malang or very bad luck, then they push, and then like hinge on the lens, right? A bit cheaper.
So only the thing is small frames will be a problem.
Small frame, very curved frames, and curved frameless. Frameless, especially try to make sure you hold on. Don't let the machine push, go more on the lens.
Means you can go against the machine.
There's a chance if let's say the shape is not right, especially if let's say that's a big curve and it push on the center.
Okay, we'll put it on.
Nothing, no power. You can check any cylinder power, nothing. It's basically flat, no power at all.
But you can tell if you use a polarizer and check, you can see distortion on the cheaper lenses, right? You know, when they actually use the polarizer,
It shouldn't show as power technically. Shouldn't show as power.
Because like some actually curves, the curves are so curved at the point where you see distortion on the sides.
It's the stress point, right?
That's the point, yeah.
Stress point.
The way the design doesn't do the stress point thing.
Okay, one more. Especially if let's say a customer is using this, for example. One more feature that I really like to show is compare feature. So you are comparing two multifocal. But if let's say you have both feature on, lens meter and spectrometer,
You can balance.
And kalau ni prism.
Prism.
boleh? You have the PD, right? Okay. You don't show first. But just make sure I have the PD, actual PD. PD height 24.5. Yeah. But it's multifocal lah. It's easier for us to check. This and then that's fine. Kong, is everything okay? I'm sidetracking. If you think that this is enough for now, you can log out already, Kong.
Okay. Okay, so
It's already
So-
2 hours. I'm just feeling sorry for you guys.
it's okay. It's okay. It's good to know.
It's okay. Yeah. If anyone wants to still
mm.
listen to what I'm doing and have questions, just let me know.
So you still demo for how long?
I will just be there for today only. But unless they request more, then I will come again.
Mm-mm. Okay.
Because in terms of lens, they have more information and we don't know what brand they are using.
Mm.
Okay. PD 24.5, 24. 28 or 26 one side, left. 6. $24.5. We don't have a reference. This one is in MM. Okay. 26, 28. It's a lot better lah. This is distortion. This is minus 1.5 unwanted aspect. Oh, a circle is distance power is yeah. Circle, blue circle is distance power. Red is the near power. Yeah. So but this is a quite long corridor as well. From 0 power to maximum reading 1.5. $13.5 tolak 1. Store lah. Corridor is store.
How do you tell again? Sorry, how do you measure?
So you get ADD power, maximum ADD is 1.5. So 1.5 ends here. So this is starting point of 1.5. So you just put it on the side like this. 50.5, I would say. Or 16 lah. 16. Okay, so 16 is the reading area, the starting of the reading area. And then we want 0 lah. 0 start from 2. You will say 2 minus 16. 12 lah. But 12, this is easy law, right?
Yeah.
Easy law is the reading corridor is starting from the middle of reading, right? So 2, 2. Correct. EC law corridor counts from distance to the middle ADD, right? Reading area 4 mm, it's in the middle, right?
Yeah.
So this, I count from the top, 12. So plus 2, 14.
Okay, that means the center of the circle, bottom here.
Yeah.
Okay.
So you can
I
actually,
think you can just manually count, like 2.
but maybe not that accurate because this one is here, 0. This one is 19.5. So we want to know whether which area, because each brand have different corridor.
Can you tell the prism?
Oh, rainbow. So even at the distant power is 4.25 in.
Yeah.
You request?
4.5.
Or slightly lesser lah. Left eye? Oh, 4.5. Left eye is correct, 4.5. This is 4.25, slightly lesser. But yeah, it's quite okay lah. Okay lah. Terus saja.
Okay, at least you get 4.
I don't recommend because you cannot do. It depends. If you are the person that would really need the horizontal marking, yeah, this one cannot do. You know, when you etch, you just want the horizontal marking to make sure when you cut the lens in, it's correct. It doesn't move. If single vision have 3 dots, but it's along the axis, it's possible to do horizontal, but you need to calculate on your head, on top of your head. Lah. It's a bit more technical. If you really want the horizontal line. If you the type of person just mark the axis, it's fine, and then just edging, it's also okay. But certain people just want that horizontal line. I don't know why. Because they're used to it. Lah. But to be technical, I wouldn't encourage edging. I would encourage more upselling. When you have the understanding of certain multifocal lens, you check the one before, they are using a very high-end lens, they want to go for lesser or different brand, you can already know what's going to happen. So that's the reason why even though you give Hoya high-end, Isilor high-end, it doesn't work sometimes. It's because of the prism design. So this is the, at least you know now lah. You can compare why both is expensive, why it doesn't work, why you cannot switch. So this is the component that lead to that. But you have to have the understanding lah. So if let's say Hoya, what kind of design you're looking at? If it's a EC law, what kind of design? Zeiss, what kind of, you sell Zeiss as well?
Yeah.
Yeah, Kong, anything you want to ask, Kong?
I think it's okay for today.
Okay.
Yeah.
Okay,
So
we'll
we
continue
need-
tomorrow. Don't worry.
We need some
So
time
tomorrow
to,
we're just gonna go through with the slit lamp, auto ref, and also if we have time, the SP1P as well.
Okay, sure.
And if you have any question regarding Solos for now, just let me know. Tomorrow I can try to do something about it.
Okay, so I asked the team if they have any question. So I'm through back to maybe to you or to the group.
Yeah, sure. You can also the group works as well.
Okay.
Yeah.
Sure. Thank you so much.
Thank you so much for listening. I'm sorry I take more than 1 hour of your guys' time.
It's okay. I think it's good to know because I think we still need to learn more. 2 hours.
I think Solos have Solos
a lot of
is
function.
a lot of features that can be very technical. If you don't know about lens, it can be very confusing.
Got it. Yeah. So we have to equip the basic knowledge also of the lens.
But try to go through the Dr. Lee's slide. Definitely help. At least you have a basic understanding of lens first.
Sure.
Then
So
if you have more further question, I'll try to make it as easier as I can. I know it's complicated.
Okay, easy. Thank you.
Okay. Thank you, everyone.
Thank you.
Okay, bye.
Thank you, Izo. Bye.
Okay, bye. Sorry if I sidetracked too much.
Yeah, okay.
Okay, we'll see you tomorrow.
Yeah, see you. Bye-bye.
Yep, bye.